Hi everyone. So in this session, we are going to deep dive into the password encoders. And if we want to make password hashing secure and efficient, we must ensure two things. We should generate a random salt and we should slow down the hashing process. So these two things make password cracking extremely difficult. To implement this solution in our application, Spring Security provides industry recommended password encoder implementation. These implementations are capable of generating the salts automatically using secure password hashing algorithm. Some of the popular algorithms supported by the Spring Security are PBKDF, 2, BCrypt, SCrypt, Argon 2. All these algorithms are intentionally designed to slow down the hashing process and require higher CPU and memory cost. Because of this, it becomes extremely difficult for attackers to perform brute force or dictionary attacks. So let's just jump to the slide and see how login works with password encoders. Now let's try to visualize how the login process works when we use password encoder inside a Spring Security application. First, the end user enters the credential such as username and password. Behind the scenes, the Spring Security framework will fetch the hashed password stored inside the database for that username. Inside that stored hash value, there will also be a salt value embedded. So Spring Security will then extract the salt from stored hash and combine that salt with the password entered by the user. Third, this newly generated hash value will then be compared with the stored hash value in this database. If both the hash value matches, the login will be successful. Otherwise, the authentication will fail. So this is how the password verification works internally when we use passwords encoders in Spring Security. Now let's understand the password encoder interface, which is the core contract behind all the password encoding implementation in the Spring Security. Let me just go to password encoder interface. Spring Security provides many implementation of this interface based on different hashing algorithms like BCrypt, PasswordEncoder, SCrypt, Argon 2, PBKDF, SCrypt, PasswordEncoder. Apart from this secure encoder, Spring Security also provides some simple encoder that can be used in the lower environments or testing purposes. However, I strongly recommend not using them in the production application, which is no password encoder and standard password encoder. So we will explore all these implementation classes in the upcoming lectures, but for now, let's focus on understanding the password encoder interface itself. So method inside this interface are 3. So 2 of the interfaces are abstract and the third one is the default method. Let's understand them one by one. Come to the first method, which is encode method. So this method should be used during the user registration process. When the user enters a password during registration, the raw password is passed to this method. The password encoder applies the hashing algorithms and a random salt is generated automatically. The final hashed password is basically returned from here. So for example, if you are using BCrypt password encoder, then the BCrypt hashing algorithm will be used internally. The generated hash value is what we stored in the database. This is exactly what we are doing in our user controller or the customer controller class, where we call the encode method and store the returned hash password in the database. Next is the matches method. So then this method is used during the login process. Here we provide 2 inputs, raw password and the encoded password. Behind the scenes, the password encoder implementation will extract the salt from the stored hash, combine the salt with the raw password and generate a new hash value with this. So then it compares this particular newly hash with the stored hash. If they basically matches that we see in the slides, the method will return true, else it will return false. And one important thing mentioned in the document is that the stored password is never decoded, if you can see in the comments. Next, this is because hashing is a one-way process. Once a password is hashed, we cannot retrieve the original password from the hash. Next is the upgrade encoding method. This is the default method, and by default, it returns the false. This method is useful in situation where we want to upgrade the hashing strength. For example, if a system internally used a weaker hashing algorithm and later we want to rehash the password using stronger settings. So this method can indicate whether the password should be re-encoded again. In such scenarios, the password may be hashed again for stronger security. However, in most applications, a single hashing operation with a strong algorithm and a random salt is more than enough. Only high security system might require multiple hashing layers, but some password encoder implementation allow configuring this behavior through their constructor, and we will explore those configuration in upcoming lectures. So this is the overall contract of the password encoder interface in Spring Security. In the next lecture, we will start exploring the different password encoder implementation, especially the BCrypt password encoder, which is the recommended and default encoder used in the Spring Security application. Thank you, and I'll catch you in the next lecture.